Unit 3, Introduction to UML, the concepts of why we model, conceptual model of UML, architecture, classes, relationships, common mechanisms, class diagrams and object diagrams. Okay. See. So introduction to UML. See, first of all, a successful software organization is one that consistently deploys quality software that meets the needs of its users. So whenever we have to deploy the quality of software, it will be meet to needs to the users. Okay. So an organization that can develop such software in a timely and predictable fashion. So whenever we have to develop a particular software in timely and predictable fashions with an efficient and effective use of resources. So we can using the efficient and effective resources we have to use from the to develop a particular softwares. And both human and materials is one that is sustainable of the businesses. These are the sustainable for the businesses. Okay. There is an important implication in this message. The primary product of a development team is not beautiful documents. So what we say, the primary product of development team is not beautiful documents, world-class meetings, great slogans, or filters price and winding lines of source code. Rather, it is good software that satisfies the evolving needs of its users and businesses. So why you say, whenever you have to say that it is a good software, it will be needs to its users and businesses, and everything else is a secondary. Okay. And next one is the modeling is a central part of all activities that lead up to the development of a good software. So whenever we have to build a models to communicate and design the structure and behavior of system, when we build to visualize and control system architectures. Okay. When you have to implement the particular systems, then we have to communicate the structures and behavior of the particular system, and we build models to visualize and control the system architecture. Okay. So whenever we have to build models to better understand the system, we are building, often exposing opportunities for simplification and reuse. Okay. We build models to manage the risks. Okay. Next. So the importance of modeling is, see, unsuccessful software projects fail in their own unique ways. So these are the unsuccessful. Whenever we have to unsuccessfully complete the project, it will be failed. Okay. But all successful projects are like in many ways. Okay. Whenever it failed, it only our, but when it will be success, it will be many ways are there. So there are many elements that contribute to a successful software organization, and one common thread is the use of modeling. So whenever you develop a successful project, it will be main use of the based upon the modelings. Okay. See, modeling is a proven and well accepted engineering techniques. We build architecture models of houses and high rises to help their users to visualize the final product. So whenever we have to create a model, it will be used same as the final model. Okay. We may even build mathematical models in order to analyze the effects of winds or earthquakes on our buildings. Okay, next one. Modeling is not just a part of the building history. It would be inconceivable to deploy a new artifact or an automobile without first building the models. Without building the models, we cannot construct anything of that one. Okay. From computer model to physical wind tunnel models to full-scale prototypes, new electrical devices, whatever, from the microprocessors to telephone switching systems, require some degree of modeling in order to better understand the system and to communicate those ideas to others. Okay. In the motion picture industry, storyboarding, which is a form of modeling, is central to any production. In the field of sociology, economics and business management, we build models so that we can validate our theories or try out new ones with the minimal risk and our cost. Okay. So what we say, there is a modeling is the main important to develop a particular systems. Okay. The model will be real to the end of the structure. Okay. So likewise, we have to implement the model. So in that way, we can say that the importance of model. Okay. So model is the most important to develop a particular structure. Okay. Next, see, a model is a simplification of reality. Simply what we say, a model is a simplification of reality. That is, a model provides the blueprint of the system. Simply we can say it provides the blueprint of a particular system, and models encompasses detailed plans. So in that model we have to assign the detailed plans, what we have to structure, so what is the process will be developed, as well as the more general plans that gives the 3000 foot view of the system under considerations. Okay, why do we model? There is one fundamental reason is we build models so that we can better understand the system we are developing. So whenever we have to implement a particular system or developing a system, the model is the best thing. Okay, why we say using of this model we have to, as well as we have to construct the system. So in that way what we say that we build models so that we can better understand the system we are developing. Okay, next, through modeling we achieve 4 aims. First one, model helps us to visualize a system as it is or as well we want it. So what we say, model helps visualizingly or what we have to expect that one. Okay, see, model help us to visualize a system as it is or as well we want it to be. Okay, and second one, it permits us to specify the structure of the behavior system. It will be specify the what is the behavior of the particular system. So what is the behavior? So we have to identify the behavior of the particular system. Okay, and next one, model give us a template that guides us in constructing a system. Simply we can say it is one of the template. In that template guides us to how to construct the particular system. Okay, so in that way it will be guides to construct a particular system, and model documents the decisions we have made. Based upon the document we have to construct as it is. Okay, so in the modeling we have the 4 aims. First one is the it will be it helps us to visualize a system as it is or as well we want it, and it permits to us specify the structure or behavior of the system, and it gives us a template that guides us in constructing a system and documents the decisions we have to make. Okay, these are the 4 things. Okay, and next one, so modeling is not just for big systems. Even the software equivalent of a dog house can benefit from some modeling. However, it's definitely true that the larger and more complex the systems. Okay, so the more important modeling becomes for a very simple reason is we build models of complex systems because we cannot comprehend such a system entirely. So whenever we consider of a complex system, the better thing to go for the model. Okay, next one. Next, principle of modeling. Next, the use of modeling has a rich history in all the engineering disciplines that experience suggests for basic principle of modeling. So here totally 4 basic principles are there. The first one, the choice of what models to create has profound influence on how a problem is attacked and how a solution is shaped. First thing is we have to choices. So which model is better to construct our system, and if any problem is occurred, how to solve the based upon the model, using of the based upon the model. Okay, so in that way the choice of what models to create has profound influence on how a problem is attacked and how a solution is shaped. In other words, choose your model well. The right models will brilliantly illuminate the most weak development problems, offering insight that you simply could not again otherwise. So the wrong models will mislead you, causing your focus on irrelative issues. So whenever we have to choose not better the models, it will be mislead to and causing the different of errors. So in that way what we say, we have to choice to create the better model or choose the better model to implement the particular system. So because of whenever a problems occur, you can easily identify it in that based upon the models. But what the models are not good, we have to face different type of problems. Okay. Next one, second one. Every model may be expressed at different levels of precision. So each and every model plays at different levels. Different levels will be assigned. See, the best kind of models are those that let you choose your degree of details depending on who views the model and why we need to view it. An analyst and an end user will want to focus on issues of that, and developer will want to focus on issues of how. Okay, so what are the issues and how to we can develop the particular how to solve that issues. Okay, so user will be what are the issues will be there, and how to can solve that issues will be developer. So both of these stakeholders will want to visualize the system in different levels of detail or different times. Okay, in that way, every model may be expressed in different levels of precision. Next one. The best models are connected to reality. That is, all models simplify reality but make sure that your simplifications don't mask any important details. So your implication don't mask any important details. So whenever we have to choose the best model, it go for the reality the best models are current reality. So as well as we have to consider as it is that model will be based upon that model we have to construct. Okay, next, no single model is sufficient. So what we say, if we have to develop a system, we have to design different type of models. Okay, we have to assign only single model. It may be successful, it may be not successful, or it may be customer satisfied or not. So in that way we have to go for use different models. See, no single model is sufficient. Every non-trivial system is the best approaches through a small set of nearly independent models. Okay, see, if you are constructing a building, there is no single set of blueprints that reveal all its details. At that very least, you will need floor plans, elevations, electric plans, heating plans, plumbing plans. So for example, we have to construct a house. In that way, we have to define the plan. In that plan, based on which is the floor, what are the evolutions there, what are the electronic plans, and what are the heating plans and the plumbing plans. In this nearly independent means having models that can be built and studied separately, but that are still interrelated. So for example, you can study electrical plans in isolation, but you can also see its mapping to the floor plan and plumbing plan. Okay, so what you say, whenever we have to go for the electric plan, but it will be mapping to the floor plan and plumbing plan. Okay, so in that way, what we say that no single model is not sufficient. We go for the different type of models. Okay. Next, object-oriented modeling. See, in software, there are several ways to approach a model. The two most common ways are algorithmic perspective, and second one is object-oriented perspective. Okay, so go for the algorithmic perspective. The traditional view of software development takes an algorithm perspective. That is, traditional views are go for the algorithmic perspective. In this approach, the main building block of all software is the procedure or function. So here it is called as the procedure or function. This view leads developers to focus on issues of control and the decomposition of larger algorithms into smaller ones. It will be decomposed. As the requirement change and the system grows, system built with an algorithm focus turn out to be very hard to maintain. So whenever we have to changes, it will be difficult to go for the algorithmic perspective. Okay. The next one is object-oriented perspective. So the contemporary view of software development takes an object-oriented perspective. In this approach, the main building blocks of all the software systems based upon the object or a class. A class is a description of set of common objects. Every object has an identity, state, and behavior. In that process, we can easily develop. Okay, and object-oriented development provides the conceptual found for assembly systems out of components using technology that may be Java Beans or common object model. Okay. Next, the UML is a graphical for visualizing, specifying, constructing, and documenting the articles of a software-intensive system. So it will depend upon the visualizing, specifying, constructing, and documentation. Okay, the UML gives you standard way of writing system blueprints, coding of conceptual things such as business process and system functions, as well as the concrete things such as the class of the beginning of the specific programming languages, database schemas, and reusable software components. So the unified modeling language is standard language for writing the software blueprints. So it will be meant for the writing a software blueprints. So the UML may be used to visualize, specify, construct, and document the artifacts of a software intensive systems. The UML is appropriate for modeling systems ranging from enterprise information system to distribute web-based applications and even to hot real-time embedded systems. So it may be sufficient to the web-based applications. Okay, and it is very expressive language addressing all the views in need to develop and deploy such systems. So the UML is a language for that is UML is unified modeling language. Okay, so UML is a language for visualizing, specifying, constructing, and documentation. Okay, so visualizing. The UML is more than a bunch of graphical symbols. Rather, behind each symbol in the UML notation is well-defined semantics. So, in the visualizing means the UML has a different type of graphical symbols are available. In the based upon the graphical symbol, we can assign the different of rules and regulations. Okay, in this manner, one developer can write a model in the UML, and another developer or another tool can interpret the models unambiguously. So, one based upon the developer, you have to do different tools or UML models, whatever may be. Okay. And specifying means building models that are precise, unambiguous, and complete. And constructing, the UML is not a visual programming language, but its models can directly connect to the variety of programming languages. Okay, directly it will be connected to the different type of programming languages, not from the visual programming. Okay, and documenting, a healthy software organization produces all sorts of artifacts in addition to raw executable code. These artifacts include requirement, architecture, design, source code, project plans, test, prototype, and release. These are the different type of artifacts in documentation. This is the maybe requirements kaavachu, architecture kaavachu, design kaavachu, source code, project plan, testing, prototype, releases. Everything will be depend upon the documentations. Okay. Next, history of UML. The unified modeling language and industry standard graphical language for specifying, visualizing, constructing, and documentation the artifacts of software system, as well as for business modeling. Okay, the UML uses mostly graphical notations to express the object-oriented analysis and design of software projects, simplifies the complex process of software design. Okay, and why go for the UML one? It is a diagrammatical or pictorial, thousands of words, and use the graphical notations to communicate more clearly than natural language and code. So make it easier for programmers and software architects to communicate, help acquire the system process. Okay, and even not dependent on any language of technology, it moves as the fragmentation and standardizations. Okay. Next, see creating the UML. See other methods: Booch method, object-oriented modeling technology, and object-oriented software engineering. This is based upon the so Booch and OMT is connecting the unified modeling method, and go for the other and OIC UML 9 and 1.0, 1.1, 1.3 is the unified modeling language, and 1.520. Okay, in the OMG experience in 1917 and the final submission 77, 97 and Jan 96. So UMS partners June. Okay, so whatever they have to using the first of all unified method and go for the 1.1, 1.3, they have to implement the unified modeling languages. Okay. See, mid 1970s, object-oriented modeling has appeared. 89-94, 10 more than 50 modeling languages, and 90s Grady, Booch, and Jacobson, Ramberg. These are implemented the object-oriented analysis and design. Okay. So James Ramberg uses for analysis data anticipation system describe the object models and static structure of the system like class, object, and state diagrams. And Jacobson is the use case requirements capture, analysis, and high-level design with use case diagrams. Okay. In 96, we have the sum of method rational form 7, 1.0, 97.1, 98 revision of 1.25, and 2005 the UML of 2.0. Okay. So Jacobson, Ramberg, and Booch, these are implemented the object-oriented analysis and design. Okay, so which is the static, which is the dynamic. So what are the requirements we have to perform? How to everything, every symbols we have to assign the different of rules and regulations. Okay. Next, the conceptual model of UML. See, understand the UML you need from conceptual model of the languages, and this require learning three major elements. The first one, UMS basic building blocks. Second one, rules. Third one, common mechanisms. First one is the basic building blocks. Second one, rules. Third one, common mechanisms. Okay. In the basic building blocks of UML, the vocabulary of the UML encompasses the three kind of building blocks. There are the three kinds. First one is things. Second one, relationship. Third one, diagrams. So these are the three kinds of building blocks. First one is the things, relationship, diagram. In go for the things, there are four kind of things in the UML. First, structural thing, behavioral thing, grouping thing, and notational thing. So what are the four things? Are structural things, behavioral things, grouping things, and annotational things. These are the four. So first we go for the structural thing. Structural things are the nouns of the UML models. These are the mostly static part of a model representing elements that are the either conceptual or physical. Okay, in all there are 7 kinds of things are available. The first one, classes, interfaces, collaborations, use cases, active classes, components, nodes. These are the 7 kinds of structural things: classes, interfaces, collaborations, use cases, active classes, components, and nodes. These are the 7 kinds of structural things. Okay. So now first, class. So what is a class? Simply we can say set of objects. See, class is a description of a set of objects that share the same attributes, operations, relationships, and semantics. Share the same attributes, operations, relationships, and semantics. A class implements one or more interfaces, and graphically a class is rendered as a rectangle. Usually include its name, attributes, and operations. So the symbol is, that is graphically a class is rendered as rectangular. There is a 3 parts: name, attribute, and operation. So one of the part is there is a responsibilities. Okay. See, window, origin, size, open, close, move, display. Okay, so window is the class name. These are the properties of window. There is the origin and the size. These are the proper operations. There is a open a window, close window, move to window, and display the window. These are the operations. Okay. In go for the attributes, we have to assign some of the symbols. There is a so the given properties are public or private or protected. Okay. So class name, attributes are properties, operations. So class name is the window, attributes are origin and size, operations are open, close, move, and display. Okay, this is the representation of the class diagram. So class name, attributes, and operations. Some of them can assign. The other one is the responsibilities. Okay. Next, interface. Interface is a collection of operations that specify a service of a class or component. So it provides service to the other class, that is called as a class or component. An interface therefore describes the externally visual behavior of that element. An interface might present the complex behavior of a class or component or only a part of the behavior. An interface is rendered as a circle together with its name. That is simply you can say circle. Okay. An interface rarely stands alone, rather it is typically attached to the class or component that realize the interfaces. That is called as the interface. Simply we can say it provides specify a service of a class. That is called as a interface. This is the symbol of interface. Okay. Next, collaboration defines an interaction and is society of roles and other elements that work together to provide some cooperative manner. That is called as a collaboration. Okay. So therefore a collaboration has structural as well as behavioral dimensions, and give a class might participate in several collaborations. This is the collaboration symbol. Okay, there is an ellipse with dashed line. There is an ellipse with dashed line. It is called as a collaboration. That is an interaction society of rows and other elements to work together, provide some cooperative behavior that bigger than the sum of all the elements. Okay. Use case. Use case is a description of set of sequence of actions that a system performs that yield an observable result of value to a particular actor. Use case is used to structure the behavioral things in a model, and use case is realized by a collaboration graphically. A use case is rendered as an ellipse with solid lines, usually including only its names. It is an ellipse with solid lines. Okay, it is the name of the use case. Okay. That is a use case. Only 7 things are available. See, class, interface, collaboration, use case, active class, component, and nodes. Okay, interface, collaboration, and use case. So next active class is on the next class. Okay.